next one is potentiometric biosensors. So before that, let us see potentiometric titration. Potentiometric potentiometric titration is the basic concept for potentiometric biosensors. So just consider a very simple setup, electrochemical setup to conduct titration. One electrode is it is a big glass beaker. One electrode is AgCl, and there will be a burette, it will be filled with HCl, and there is one more electrode, it is glassy electrode, and inside the glassy electrode there will be a second AgCl electrode, AgCl electrode, and now it is these two electrodes, AgCl electrode, first electrode and second electrode. This first electrode is said to be a reference electrode. It is a reference electrode, whereas it is an indicator electrode. So the beaker is filled with neutral buffer solution, say KOH plus 0.1 mole of HCl. So this one is a glassy electrode. Glassy electrode. Its bottom shape is in bulb form, in curved form, and it is a semi-permeable. It is made up of semi-permeable glass, that is porous glass. Glass bulb is made up of semi-permeable membrane, so fused glass. So it contains many pores. Its ranges from around 40 nanometer to 1000 nanometer. Okay, so it permits only H plus ions. Now this glassy electrode is filled with again it is filled with KOH plus 0.1 mole of HCl. It is a neutral solution. pH is 7. Now the wiring connections. Wiring will be these two electrodes, reference electrode and the indicator electrode will be connected to voltmeter. So there is a pellet or magnetic stirrer. Magnetic pellet. It is used to maintain homogeneity of the solution. So in the beginning, imagine that you have not added any HCl. You have not added any HCl. The voltmeter readings will show 0 volts. 0 volts. Okay. Because it is the solution in the beaker is same as like that of the solution in the inside the glassy electrode. So both are both are at same pH. There is same concentration of H plus is there. Once it is disturbed, the concentration of H plus differs. It will, your voltmeter will show some deflection. This is how. So when you titrate with the help with the HCl solution, that is when you add HCl drop by drop into the glassing into the vessel. When H plus concentration increases, since it is a semi-permeable, this glassy, that is not the entire part, only the bulk part is semi-permeable. It easily allows H plus ions. So H plus ions are easily passed through the semi-permeable membrane. Okay. And then some polarization takes place, and finally it will generate a change in electric potential inside the glass vessel, or it disturbs the equipotential. So when the potential is deviated, that is either it will increase or it will decrease, okay, based on the concentration. In this case, since you are increasing H plus concentration by means of HCl, definitely potential difference will increase, and so this indicator electrode will indicate how much potential or electric voltage changes. Now, based on the concentration of HCl, electric potential will increase. So this is so while titrating with the HCl, electric potential increases. So this idea is very basic for potentiometric biosensor. Now I will tell you one example based on this potentiometric titration. It is a pH, working of a pH meter. pH meter, it is a conventional setup. It is even nowadays it is used in laboratory to know pH of solution, given solution. Okay. So in a pH meter, what is very important is the glassy electrode. Glassy electrode. Because bulk part of glassy electrode is having nanopores. These nanopores easily permeates H plus ions. That is the main part of potentiometric biosensor or pH meter. So pH meter will be having two compartments of glass electrode. This is one compartment and this one is another, outer is another compartment. Here you will add AGCL reference electrode, and there is one more electrode, AGCL indicator electrode. Okay. Now wiring will be like this. It's connected to voltmeter, or okay, let us say it is a voltmeter, and then it will be connected to voltage to pH converter, then display pH display. It is voltage to pH converter. This is a voltmeter. Okay, just for your understanding, I have included all these things. Beginning, it will show it will be in a neutral, so 0 voltage. It's the same solutions are inside it. KOH plus 0.1 mole of HCl. Okay, and in the second compartment, where reference electrode is there, it is also filled with KOH plus 0.1 mole HCl. Now you have fixed your, this is your pH meter electrode. You have put your pH meter inside the vessel, where a standard solution KOH plus 0.1 mole HCl is there. 0.1 mole HCl. Okay. It is a burette filled with HCl. It is a burette filled with H2O. H2O. So of course there is a magnetic cell. Okay, magnetic pellet. Now we will, to understand the working of conventional pH, it is a conventional setup, conventional pH meter. Okay, uh, I will tell you three cases. In one case, I'm going to add H2O drop by drop. In the second case, you just imagine that I'm going to add HCl. The third case we are going to add KOH. Just for your understanding how the pH meter works, how the readings, different potentials and different pH values are produced. To understand that, I will tell you three examples. The first case, H2O is used inside the beaker and drop by drop it is added. Okay, just imagine. And to understand ion permeation and electrostatic attraction, uh, I'm going to enlarge this region, this bulb region. Okay, so this is the bulb region. It will be like this. See, inside the glass electrode, glass bulb, there will be some 0.1 mole HCl plus KOH solution is there. So there will be some standard concentration of H plus will be there. 4 H plus. Now you have added H2O. The external solution is also consists of KOH plus 0.1 mole HCl. C, same concentration of hydrogen ions or HCl is there in both solutions. So this since it is a semi-permeable membrane, H plus ions easily pass through it. Since concentration of H plus ion outside the glass bulb electrode and inside the glass bulb are same, four H plus, and this once this 4H plus ions enters or enters this semi-permeable membrane, polarization takes place, and based on the polarization, same concentration of H plus ions will be attracted here. Okay. Now, this indicator electrode is in contact with this glassy electrode. So it measures this potential difference. Since this potential difference, that is concentration is equal, this potential difference is 0. It will generate 0 potential difference, and the voltmeter readings will show 0 voltage. Okay, 0, and your pH meter will display 0, or it will be calibrated. Sorry, it will not display 0. This 0 voltage will be calibrated as 7 pH. Or pH equal to 7. It means the solution is neutral. Okay. So 0 voltage is calibrated, is converted as 7 pH or neutral. Now in the second case, instead of H2O, imagine that you have added HCl into the beaker. Now we will see what happens. So when H plus is added drop by drop, since more hydrogen ion concentration is generated, more H plus ions are allowed to pass through this semi-permeable membrane, and so H plus, H plus, H plus. Okay. Now the concentration difference is there. See, inside the glassy the beaker, concentration of H plus will be remain same because it is 0.1 mole HCl. It is fixed. But outside, By means of this burette, you are adding some foreign HCl. So this HCl permeates, more HCl permeates, and it generates potential difference, overall potential difference between the reference electrode and indicator electrode. Now voltage starts to increase, it will show some value, and it is converted into acidic medium. Acidic medium. So it will pH value will be displayed as 2. Higher voltage. When you go towards higher voltage, the pH number will decrease. It means hydrogen ion concentration is increasing. pH is equal to 2, but hydrogen ion concentration is increasing. Okay. Now it is said to be in acidic. Okay, acidic. The third case, instead of HCl, you add NaOH. NaOH or KOH is going to be added. And when it is added, definitely H plus ions able to permeable through the glassy membrane will be minimized. Okay, will be minimized. So there will be only few H plus ions pass through the semi-permeable membrane. Only few H plus ions. Now the concentration difference will be there, so it will generate a negative potential. Negative potential. Potential, electric potential will increase opposite direction. Now this negative potential is calibrated as, or decreasing potential electric voltage is calibrated as pH, increasing pH, say 13 or 12. Okay, so it means pH, when pH is equal to 13 means concentration of H plus will be minimum. Okay, so it indicates alkaline, or sorry, base media. Then your solution is said to be a base. So this is how a pH meter works based on potentiometric titration, and it will be calibrated. That is, voltage will be converted to corresponding pH values based on H plus ion concentration, and then you will come to know whether the given solution is changing to neutral medium, changing to base, or changing to acidic medium, or else it remains in neutral medium. So this is all about conventional pH meter. In the next class, or conventional pH meter, it is an example for potentiometric biosensor. In the next class, I am going to tell you how a pH sensor works based on nanotechnology by using some transistors.